Hey, welcome to Mr. Nelson's class and another stoichiometry problem. Again, we're going to be working with practice sheet number 6, problem number 2 right now. So as you can see, it's a long problem, and we may attack this a little bit differently than what we did with even question number 1. So let's go ahead and look at this. It says hydrochloric acid will attack and corrode many of the metal elements, resulting in the generation of hydrogen gas and producing a solution of metal chloride. In class, Mr. Nelson demonstrated this reaction using the metal zinc. He placed zinc in a flask with hydrochloric acid, creating hydrogen gas, which filled the balloon and left zinc chloride in solution. If Mr. Nelson wanted to fill the balloon with 2 liters of hydrogen gas, he would need to produce 4 grams of hydrogen gas. How many grams of zinc metal would theoretically be needed to produce this much hydrogen gas if he had an excess of hydrochloric acid? So let's go through and let's highlight a couple things that are important. The first part, from here up, okay, from there up all the way up to the beginning, is kind of like blah, 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 blah. So we don't need to worry about that. So we're going to look at the second part. He placed zinc in a flask with hydrochloric acid. So that's where we start down. We know that he put zinc. So we're going to highlight that. Okay. And hydrochloric acid. And we'll highlight that one. Okay. So we put those 2 in there, and he created hydrogen gas. Okay. So we'll highlight that. That's what he created, which filled the balloon, and he left zinc chloride. So zinc chloride was in solution. So there's our last one. So we have zinc and hydrochloric acid created hydrogen gas and zinc chloride. So let's go down to our skeleton equation. So we're going to say zinc is Zn. We're going to add to that hydrochloric acid. Now hydrochloric acid begins with H, and hydro means no oxygen, so it's just hydrogen and chlorine. And hydrogen is a +1 and chlorine is a -1. So we're going to add to that just HCl. Okay. Now that's going to yield hydrogen gas, so hydrogen. Now the question is, if we have it by itself, is it diatomic? Well, hydrogen gas is diatomic, so we have to put that in there. Make sure it's diatomic. And zinc chloride. Now again, zinc is what charge? That's what we have to know. Chloride is a -1. So if I tab all the way over here, I can tell you right now that chlorine is a -1. But what is zinc? Well, let's go to the packet. Let's see. Zinc is right here. So it's not an A group, but is it part of that monoatomic ion? Or is it something we have to figure out what it is? Well, there's no Roman numeral, so it must be a type 1. So let's go down to page 13 or 14. Page 13, and let's scroll right here. Zinc is a +2. So if we go back to the question, we know that zinc right here is a +2. So they don't cancel each other out, so that means they need to crisscross. So I need to have 2 chlorines and 1 zinc. So we're going to add to this 1 zinc, Zn, and 2 chlorines. And there is our formula for zinc chloride. So now what do? We have to go ahead and we have to balance the chemical equation. So we have our unbalanced one. There's our skeleton one. So we're going to go ahead and get down here. And we're going to have zinc on this side. We have hydrogen on this side. And we have chlorine. Okay. So now we have to go to the other side. We're going to put the same elements. So we have zinc, hydrogen, and chlorine. Okay. Now how many do we have on each side when we balance it? I have zinc all by itself here, so I have a 1. So I have 1 zinc. On this side, I have 1 zinc. I have 1 hydrogen on this side. And on this side, I have 2. Again, we're looking at the subscripts. If there's no subscript, that means that that there's only one of that. So let's go on this side for chlorine. I have one chlorine because there's no subscript. And on this side, we have a subscript of 2, so we have 2 chlorines. So we don't have to change the zinc, but we're going to have to change the hydrogen and the chlorine. So what do we want to change first? Let's just look at this real quickly, and we say, let's do the hydrogen or the chlorine. It doesn't matter. I need 2 of each one of those, so we're just going to put a 2 right there. That changes this to a 2, and it changes our chlorine to a 2. And if I pull those back over there, I have 1 and 1, 2 and 2, 2 and 2. That's good. Let's double check the problem. 1 zinc here, 1 zinc here. 2 hydrogens here, 2 hydrogens here. 2 chlorines here with that, and 2 chlorines there. So that is balanced. So our molar ratio is 1 to 2 to 1 to 1. Okay, so 1, 2, 1, 1. And again, if you want to put your numbers there, which I think it might be a good idea to do that, to put our numbers right there. Okay, sometimes I even like to, either make them bold or, okay, because we are going to need these at a later point, or at least we're going to need 2 of them when we do our stoichiometry. So after we balance our equation, we need to go ahead and start with our stoichiometry. So we're going to start with, if you remember the thing, what is the number in the packet that we have? In this case, with grams, because we're doing mass to mass. So we have 4 grams of hydrogen gas. Okay. So we're going to start right off here with 4 grams of hydrogen gas. And I'm going to change this down just a little bit. I'm going to move all these, I think. Okay. So we're going to have 4.0000 grams of hydrogen gas. Now we're going to put our times in our line, and we're always going to put 1 mole at the top. So 1 mole of hydrogen gas weighs how much? Well, I have 2 atoms of hydrogen. Each hydrogen weighs 1 gram, so really I have a total of 2 grams of hydrogen gas. So we're going to go ahead and underline this. So there's our conversion factor from grams to moles. These are equal to each other, so 1 mole of hydrogen equals 2 grams because there's 2 atoms of hydrogen in it. Next, what we're going to do is we're going to do our next one, our center part of that, where we are going to do our mole to mole. Now, this is where our balanced chemical equation comes in. So on bottom, we'll start off with what's on bottom. We're going to have moles of hydrogen gas. Now we go up here and we say that's 1 mole of hydrogen gas. So we're going to put in there 1 mole because, again, it's 1 mole. This number right here, if I use it and put the word moles after it, that's what it equals. If we look at our stoichiometry map, you can see that that's a coefficient, and that's what we're going to use. So we're going to put down 1 mole of H2. And that's going to equal what the question is, how many grams of zinc metal would theoretically be needed to produce this much gas? So we're looking at this one right here, zinc metal. Now, that's 1 mole of zinc. Zn. Okay. And so now I have it in moles of zinc, and now I have to change it from moles of zinc to the weight. So we're going to come back down here, and we're going to put down 1 mole of zinc, Zn, equals how much? How many grams of zinc? And I don't know how much the atomic weight of zinc is, but I can look at my periodic table. Scroll back up to the periodic table itself. Find zinc, it's right here, so it's 65. So we'll go back to the question, and we know that 65 grams of zinc equals 1 mole of zinc. We'll underline that. And we know that our answer is going to be in grams of zinc, but we have to get rid of all the other stuff to make sure that's the only thing that's left. Now remember, anything that's on top and on bottom, they're going to be on top and bottom, we can get rid of. So grams of hydrogen gas, I have it on top, and I also have it on bottom, so we can get rid of it. Moles of hydrogen gas, I have it on top, I also have it on bottom, I can get rid of it. And again, remember, this is a nice way to see if you didn't make a mistake. I have moles of zinc here, and I have moles of zinc down here. Okay, the only thing that I have left is our grams of zinc. So now all we have to do is the math. And remember, we take start with our original number, this 4 grams, and we multiply by the top and divide by the bottom, and then put whatever unit. So we're going to get rid of this, and we're going to put 4.00. We're going to divide that by 2, and we're going to multiply that by 65, and that equals 130 grams. So if I put 130 grams, and we can double check that, again, we don't have to multiply by the 1 or divide by the 1 because 1s do not change the value of what we're doing. So 4 divided by 2 times 65 equals 130 grams of zinc. Okay, now we need to go back up to the original problem, and we have to figure out how many significant figures does our answer need to be in. Well, the number that we're talking about is this one right here. This is a measured amount. This right here is just 2 liters. It's not really part of the question, so we're going to put it in 3 significant figures. So here I have 2 significant figures. There's 2 ways I can do this. One way, I can just put a decimal right there. Now my trailing 0 becomes significant because of the decimal, or I could have put it in scientific notation. I think it's just as easy to put the decimal in right there. We're going to highlight our answer, and voila, we're done. So that's it for question number 2 on practice sheet number 6. Hey, as always, go Mohawks. Nelson out.